Hello, seniors. Today we're going to continue with electronic assignment 21, which is about the antiderivative and indefinite integral. If you remember from last class, we have seen the concept of an antiderivative and we've defined it as the opposite operation as derivatives, right? So that's basically what antiderivative is about. We have seen the general rule to find the antiderivative, just as we have the general rule for finding the derivative of a function. We now have this rule for finding the antiderivative of this type of function, right? One thing you need to remember is that whenever we find antiderivative, we always have to add a plus c at the end whenever we're talking about indefinite integration, because there are actually infinite possible results for an antiderivative, as we can pick any constant number at the end that will make that when finding the derivative will make this term zero. So there are different possibilities for that. Okay. So we're gonna continue we did some exercises yesterday, if you remember. And we're going to continue today by working with these properties, which are basically the same properties we've seen in derivatives. Let's see. Antidifferentiation is also known as indefinite integration and is denoted with an integral symbol, and this is the symbol for integration. For example, the integral or the indefinite integral of x cubed is x to the power of 4 times 1/4 plus c, okay? That's why it's called indefinite integration, because we're adding a plus c, which we don't know its real value because it can take any value actually. So whenever we add a plus c at the end, we talk about indefinite integration, because there's no one unique solution to the problem, right? Later on, we're going to see definite integration, and you'll see that the plus c disappears. Okay. So this means that the indefinite integral or antiderivative of x cubed is 1/4 x to the power of 4 plus c. These rules will help you find indefinite integrals. Okay, so these are some of the properties or rules for integration. If we have, the first is the power rule, right? If we have the integral of x to the power of n dx, then the integral of this expression is raising the exponent by 1 and dividing the whole expression by the new exponent, right? So 1 over n plus 1 times x to the power of n plus 1 plus c, where n must be a number different from 1. Okay, so for example, it says the integral of x to the power, actually there's a mistake here, it should say x should be different from -1. There you go. Because if it's -1, then we're going to get here 1 over 0, right? -1 plus 1, that's 0. So this is undefined, right? So n needs to be different from -1. So for example, here's an example. The integral of x to the power of 7 dx is equal to x to the power of 8. We increase the exponent by 1 and we divide the whole expression by the new exponent plus c, right? That's the power rule for integration. Then we have the constant rule, which says the integral of k dx is kx plus c. So for example, if we find the integral of a number, of only a number, the integral of 3 would be 3x plus c, right? If you try finding the derivative of 3x, if we find the derivative of 3x, you would realize that the derivative of 3x is 3. Okay, so we go back to this place. That's why the integral of 3 would be 3x plus c at the end, because it can have any other constant number at the end. Okay, then we have the constant multiple rule. It says the integral of k times f of x dx is the same as saying k times the integral of f of x dx. That means that I can take out the constant value outside of the integral and find the integral of only the function which is left inside. For example, this situation, right? If I have the integral of 4x squared dx, I can take out this 4 out of the integral and just work with x squared. Okay, so this is the same as saying 4 times the integral of x squared dx. So I only integrate x squared, which is x cubed over 3, right? So I only add the 4 later on in the final result. So it's 4x cubed plus 3 over 3 plus c, right? Don't forget the plus c. Finally, the last rule is the sum or difference rule, which says that if I have the integral of a function plus or minus another function, then I can separate this integral into two different integrals. I can do the integral of f of x dx and then plus or minus the integral of g of x dx. For example, if you look at this expression, the integral of 2x squared plus x minus 1, I can separate this and work as, let me write one step more here just to make this clear. I can write this as the integral of 2x squared dx plus the integral of x dx minus the integral of 1 dx, right? So I can only write, I'm going to write 1 dx. So I can separate all of the different terms of the function into different terms and integrate them separately, right? So the integral of 2x squared, that's 2 times x cubed over 3. The integral of x would be x squared over 2. And finally, the integral of 1, that's x, right? And remember, we have a negative sign in front. That's why we leave this as negative x, right? And then the plus c at the end, because we may have different solutions for that. Okay, we're going to read this. It says, if f prime of x is equal to f of x, we write the integral of f of x dx equals f of x plus c. So a greater function, a function that has a 1 degree more than this f of x plus c. That's what we're doing when we integrate the function. The expression integral of f of x dx is called indefinite integral. The integral of f of x dx is read as the antiderivative of f with respect to x, or the integral of f with respect to x. That's how we read this whole expression. So here you have the explanation of what each term means. The variable of integration is represented by this dx over here, right? The integrand, the term that we're integrating, is f of x in this case. And then here we have constant of integration is this value of c, which we always need to add whenever we're working with indefinite integrals. Okay, so let's see some examples in which we're going to apply all of the different rules we've seen. Here's a tip that I already told you last class. You can always check your answers to your indefinite integrals by differentiating your answer and checking to see that it equals the integrand. So that's an easy way to check if you're doing the right thing, okay? So let's see with some exercises. We're gonna find first part A. It says the integral of x to the 6th power with respect to x, okay? So for this case, it's easy. We just apply the power rule. So we increase the exponent by 1 and we divide the whole expression by the new exponent. And then don't forget about plus c, okay? If you want, you can check your result. Let's do this in blue. I'm gonna find the derivative of x to the 7th over 7 plus c. I'm gonna find the derivative of all this. So it'll be, remember the opposite. When we find the derivative, we take down the exponent and it decreases by 1. Then we have the divided by 7, this one over here. And then the derivative of c is always 0, right? So we get, you see that we simplify the 7s there, and we get as a result x to the power of 6, which is what we had at the beginning, right? So this is correct. Let's move on to part B. Part B says the integral of 4 dt. Now we're integrating with respect to a variable t. That means that the variable that needs to appear is a t instead of being an x, right? So I need to integrate 4. If I want to integrate 4, it's just 4t, right? Because we had t to the power of 0. So if we increase the power of 0 plus 1, we're going to get t to the power of 1. And then we need to divide this by 1. but there's no need to show that, right? 4t divided by 1 is the same as saying 4t. So this is 4t plus c. Once again, if you want, you can check your result. We can find the derivative of 4t plus c, and we're going to get as a result 4 plus 0, right? So we get only 4, which means that we got the original function here, and that means that it's correct. Okay, let me mark this as an answer, and this is an answer. There you go. So I hope this is getting clear for you, seniors. Let's see now part C. It says the integral of 3x to the power of 5 dx. Okay, this is a case of this one over here, right? The constant multiple rule. I can take out the constant number outside of the integral before doing the integration. So this is the same as, or if I want, I can leave it there. It's the same thing, right? But I can rewrite this as 3 times the integral of x to the 5th power with respect to x. So I'm only integrating this expression, which for that we're going to apply the power rule. So this would be 3 times x to the 6th power divided by 6. We increase the exponent by 1. And then plus c, right? So this would be the answer. Actually, I can simplify 3 with 6, right? We're gonna get 2 here, 1 here. So the answer would be x to the 6th power divided by 2 plus c. This would be the answer. As always, you can check your result, right? We're gonna do this in blue. If I want to check the result, we're gonna say that the derivative of x to the 6th power divided by 2 plus c is equal to derivative. We take this down and we decrease the exponent by 1. So this is 6x to the 5th power divided by 2 plus 0, right? Because the derivative of c is 0. So then I simplify terms. This is 1. This would be 3. So I get as a result 3x to the 5th power. So I'm getting the original function we had here. So that means that our integration is fine. Perfect. Let's move on to exercise D. Exercise D says, find the integral of 3u4 plus 6u squared plus 2 with respect to u. So now our variable of integration is u. But we're doing exactly the same thing. In this case, we can apply this rule over here, in which we separate all of the different functions before integrating, right? You don't need to show that process. You could directly find the integral of this plus the integral of this plus the integral of this. But since this is the first time we're doing this, I'm going to show the step-by-step process. This is the same as saying integral of 3u4 du plus integral of 6u squared du plus the integral of 2 du. Okay, we separate all of the different terms of the expression and find the integrals of each of them independently, right? So this is the same as saying this is equal to the integral of 3u4, that would be 3 times u5 divided by 5. I'm going to add the plus c at the very end of this, okay? You don't need to add for each of this. Plus, the integral of this would be 6u cubed divided by 3, okay? And finally, the integral of 2 is 2u, so plus 2u. And we don't need to divide by anything. So then we add the plus c, okay? At the very end of everything. So I see that I can simplify some terms. This would be 3, we'll write it as 3 over 5 u to the power of 5 plus 2u cubed plus 2u plus c. So all of this is the result of the integration of this expression over here. As always, you can try to see if this is correct. So we're going to do that right here. We're going to find the derivative of the whole expression. 3 over 5 u fifth plus 2u cubed plus 2u plus c. We're going to find the derivative of all of this. So we apply derivatives, right? We take the exponent down and decrease the exponent by 1. So this would be 3 times 5u fourth, and all of this is being divided by 5, plus the derivative of this would be 2 times 3u squared, right? And finally, the derivative of 2u is just 2. Okay, finally, we're going to see the last exercise, which is part E. Part E says the following. We want to find the integral of x plus the cubic root of x. And this is with respect to x. X plus the cubic root of x with respect to x. Okay, so I will have to apply both the sum or difference rule, and I need to convert this to the exponent form in order to be able to apply the power rule. Okay, so that's what I'm going to do. I'm going to separate this first, and I'm going to say that this is the integral of x with respect to x plus the integral, and instead of writing the cubic root of x, I'm going to write this as x to the power of 1/3. Okay, and this is with respect to x. So now I'm going to find the integral of the whole expression. I'm going to say that the integral of x dx is x squared divided by 2, right? X squared divided by 2 plus the integral of x to the power of 1 cubed is 1 cubed plus plus 1, which is 4/3, right? So this is x to the power of 1/3 plus 1, which is 4/3. And then we need to divide the whole expression by that new exponent. So this is being divided by 4/3. Okay? And then don't forget plus c, because we're talking about indefinite integrals. So if I reorganize these terms, then we will have this as x squared divided by 2 plus this 3 goes up here to the numerator, okay? So this is plus 3, and instead of writing x to the power of 4/3, I can already write this as, I'm going to take this a little bit down to avoid confusion. I can already rewrite this as x to the 4th power, and this is cubic root, okay? And all of this is being divided by 4. Don't forget this 4 here, plus c. So this would be the integral of all of this expression. Let's see by finding the derivative if this is correct, okay? So if I find the derivative of all of that expression, x squared over 2 plus 3, I'm going to rewrite this as x to the power of 4/3 divided by 4 plus c. If I find the derivative of all of this, we should get, let's see, the derivative of this would be 2x divided by 2, right? Plus the derivative of this would be 3 times 4/3. The exponent decreases by 1. 4/3 minus 1, that's 1/3. And this is all being divided by 4, right? This 4 over here. So, and then the derivative of c is just 0, so we don't need to write that. Okay, so I see that I can simplify some terms. For example, this 2 with this 2, and this 4 with this 4, this 3 with this 3. So I will get as a final result that this is x plus x to the power of 1/3. X to the power of 1/3. But x to the power of 1/3 is the same as saying the cubic root of x. Okay, so we get exactly the same result. That means that we did this integral correctly. Okay, so that's how you work with this. Okay, so that's it. I hope this is clear for you seniors. It's quite easy. It's basically the same thing as derivatives. It's just applying some rules. The rules are the opposite as from derivatives, but the way of working is exactly the same. The only thing you need to remember always is to add the plus c at the very end when we're working with indefinite integrals. Okay, so I hope this was clear. If not, please let me know. We're going to work with this in future live sessions. Thank you for your attention and see you.